Thank you very much for this wonderful opportunity. It's very nice to be here, and I'm really thrilled that you have a course on archaeology and that there is a good participation for it. I look forward to interacting with all of you for participating here. So, this is a book that I have spent several years planning and writing, and it's finally out just a few months back. This book was planned in order to sort of try and help people who are studying cultural heritage, conservation of heritage, archaeology, how they can go about using remote sensing and GIS. So with this, I will start about my book. So, with or without our consent, details from our daily lives are being captured and stored in vast digital databases. If humanity were to vanish tomorrow and alien historians chanced upon these databases, centuries from now, they would have incredibly rich resources for studying humanity's past. As humans in the 21st century, trying to understand our own past, we have no comparably detailed database to tap into. Instead, we must scavenge for traces of past human activities that have survived from material form and develop expertise in interrogating these material before their secrets fade into oblivion. We rely on archaeologists to scrutinize ancient material. One second, my slide is not moving. I'm just checking. Yeah. We rely on archaeologists to scrutinize ancient material, ranging from small-scale fragments of pottery and bricks to large-scale artifacts such as individual buildings and a whole landscape or settlement. In each of these domains, scholars have benefited from scientific developments that are constantly expanding the kind of ancient material that are interrogable, and technological advances that enhance our ability to extract useful information from them. This book is an introduction to a branch of archaeology that scrutinizes landscapes, such as this, for instance, at Nalanda. Humans necessarily scar the landscape when they construct structures, forts, canals, tanks, and road networks. These scars, which can survive for many centuries, are also material records of past human activities and are therefore worthy of study. However, these scars are difficult to discern at ground level, and their value was largely unrecognized until they were observed from aerial perspective, initially from aircrafts and more recently from satellites. Lieutenant Colonel Beasley, a sapper of the Royal Engineers in Mesopotamia during the First World War, spotted distinct lines. As you can see in the center of this photo, a black and white photograph, there is a rectangular pattern that is very different in orientation from the surrounding patterns. So he spotted distinct outlines of an ancient canal in the course of his repeated flights over the Tigris and Euphrates plain, enemy territory at the time, while carrying out a survey of contested area beyond Baghdad. He wrote, "The remains of an ancient city were disclosed, which would not have otherwise have been discovered in all probability. It was the old Samarra." A more recent example here is a false color image of Bangalore. And here is a map of Bangalore from made in 1791. This map shows a four-cornered settlement and an oval citadel on its south. If you carefully analyze the satellite image, we can identify where exactly was the old settlement. I now request you to carefully look at the point I'm highlighting. Though it's fully overgrown, but still the imprints or the traces of the patterns are still discernible. We can still see this pattern of the old settlement. Apart from such images, analysts can put together spatial data from other sources, including old maps. Here, for instance, there is a map of the Portuguese town of Coilan, or what is known as Kollam today, made in 1630. Here is another map of the same location made in 1635. Here is a third map. The first two maps were made by Portuguese and the third one made by Dutch, which looks very different. It might be very difficult for the viewer to even believe it is the same place. This third map made in 1687. Then there are drawings made by people who visited, some artists, to show how the scene looked and so on. But what's interesting, if we carefully examine, we can identify the common buildings, and also we can identify the currently protected piece of wall belong actually to this very building, because that's the only building which had 3 stories, and the remains of the of this fortress, which is right now protected, also has 3 stories. Now we can also identify on satellite images which part of column belonged to Dutch and which part belonged to Portuguese by analyzing these images. This coherent spatial view allows an analyst to hunt for visual patterns in a landscape in a manner akin to an art historian examining a painting through an appropriate historical lens. Furthermore, just as a modern art historian uses technology to scrutinize what lies beneath the topmost layer of paint, advances in technology of remote sensing permit satellites to view landscape in different wavelengths and reveal hidden layers of human artifacts. I'm sure in the last week you would have been acquainted with such technologies that is available with remote sensing. So here I have shown an arrow to show the location of this particular building, which remains, and also it shows in context of what was the Dutch fortification, which is marked in yellow, and the Portuguese fortification marked in pink in this Google Earth imagery. The purpose of such analysis is to identify and understand and conserve and protect remnants of our past. This field therefore brings together knowledge from archaeology, history, art history, architectural history, heritage science, geoarchaeology, geomorphology, remote sensing, geographic information system, and cultural heritage conservation and management. Although I'm not an expert in all these domains, my research group has brought elements from each of these domains to bear in investigating landscapes surrounding several archaeological sites. So here is a map which shows all the sites that my book touches in one way or another. Not all sites we have done in a very great detail, but we, even if it is mentioned or given as an example, this map shows the location of all those sites. While all these sites are situated in the Indian subcontinent, my research has helped me recognize and articulate universal principles that I am excited to present in this book. I hope this book will be of interest to at least 3 groups of readers. I will elaborate on these groups of audiences for my book after a brief on the chapters. The book has 7 chapters. Chapter 1 is an introduction to the field and should be of interest to all readers. It begins with definition of cultural heritage adopted from UNESCO's definition and highlighting that the primary focus is on built heritage. These structures constitute the known remnants of built heritage at the site, and it is possible that hitherto unknown remnants associated with the site still exist in its vicinity. Consider the vicinity of Nalanda, for instance. When we visit the site protected by Archaeological Survey of India, we see these sacred temple structures called chaityas. There are 6 of them. And there are 10 dwelling structures, monasteries called vihara. Each has a central hall surrounded by monastic cells. This infrared image shows the protected site of Nalanda and the area immediately around it. Notice how 4 temples in the protected region lie at regular intervals along a straight north-south line. Sure enough, the infrared image suggests the presence of one unexplored mound to the south and one to the north. In the north, one can also see 2 crop marks at exactly the intervals we are expecting. So here the black or the gray dotted line shows the protected area, and within it are the protected monuments, but outside it shows marks of location identified through crop marks, which indicate places where there would have been past such monuments, because they fall in a line with the existing ones, and those marks indicate locations of old settlements. Here is one more in the southern area, just to show what is its condition at present. The central thesis of this book is that a careful study of a site's vicinity or spatial context. I call the site's vicinity in the book as spatial context. So context can lead to two important types of discovery that may improve our overall understanding of the site and inform our strategy for its protection. Firstly, the discovery of further instances or attributes of built heritage. And secondly, the discovery of artifacts such as former water bodies, canals, mounds associated with past human activity in the site. So the other things like water bodies, canals may not be direct indication, but it is definitely indirect indication. Chapter 2 describes how landscapes evolve over time and discuss the implications of this evolution for the analyst seeking to identify archaeological features from above. For instance, the well-known example of crop patterns in the field, first observed in aerial photos of World War I and II. Here you can see a circular pattern in a field, turned out to be surface impressions of buried fort wall and adjacent moat. So here is a diagram showing how a fort wall and moat would have existed at the time of it was in use. And here it is showing how over time, if there is cultivation happening in that place, how a buried moat and buried fort wall would show difference in crop color. But this is only one of many ways a landscape can morph itself, which depends on what has been happening subsequently on the surface. So here is an example how there are many different ways a landscape can morph, depending what's happening there. Even in an urban jungle like cities, one can see traces of the past layout, which are inscribed as roads or land use patterns. A ruined, disused wall becomes hindrance in mobility, and people and goods move along it, creating paths which over time become roads and remains as a permanent scar even if land use on either side keep changing. For instance, let us take an example of Old Delhi. Jama Masjid and the Red Fort, known also as Lal Killa, are easy to find on Google Earth image. Lal Killa was the citadel of a much larger fort encircling Shahjahanabad, which no longer exists now. But can we still see its scars? Let me cheat by overlaying the satellite image with this 19th century map of Delhi, which shows the surrounding fort. Now I hide the map, and suddenly you see where the fort lay. This is an example of how a site looks in an urban area. Similarly, the manifestation of sites in different kinds of land surfaces are discussed in the second chapter with examples. In the book, we refer to the landscape in the vicinity of the site as its spatial context. For a given site, we would like to identify features in satellite images of its spatial context that may provide new archaeological insights for that site. When we look at a site's spatial context today, we see only the present point in its evolutionary trajectory. For some sites, we may have historical spatial records that provide multiple snapshots of these spatial contexts as they change over time. For instance, these records may date from few years ago if we are using Google Earth images, to a few decades ago if we are using older satellite images including corona images. Corona has a different meaning today, but I mean corona satellite images. To a few centuries ago, such as using of old maps, paintings, and spatial descriptions in historical texts, like the column example. Even with multiple snapshots of a site, our data is generally too sparse to precisely infer the sequence of gradual changes to its spatial context. This lack of data forces us to guess how the spatial context evolved and to use these guesses to explain why we cannot observe certain features. Images may directly show certain surface features, while some subsurface features may only be visible indirectly through morphological expressions. For example, here is a 19th century map of Lalkot and Kilarai, Pitora. Then an image of 1965. This is an image from Corona series of satellite. Then a recent image. In most cases, recent image is what we have, and we have to hypothesize the reverse order, which is sometimes aided by old images, maps, records. Thus, this chapter 2 provides the basis for answering critical questions such as, what kind of features should I be looking for in satellite images? And why can't I see what I'm looking for in a particular image, for instance? So here is just to give an example how we have to infer the reverse order. Chapter 3 describes the various types of imaging technologies that are operational on contemporary and retired Earth observation satellites. This chapter helps the analyst answer the question, is this type of satellite image likely to be useful for my analysis? For instance, look at these images of landscape of Belur in Karnataka. The one on the left shows the circular moat. You can see a red circular shape, red pattern in the center of the image. So the one on the left shows the circular moat that surrounded the old settlement, whereas the natural color image on the right, though of higher resolution, doesn't show the circular pattern so clearly. The chapter also reveals some of the science behind these technologies to help answer the inevitable follow-up question, why and why not? Such as this diagram, showing how light of visible wavelength versus infrared wavelengths is reflected off a leaf, causing this bright vegetation pattern in infrared imagery. So as you can see, the visible wavelengths are reflected off the top of the leaf, whereas the infrared goes further deep and diffuses much more. And therefore, we are able to see much brighter or much more difference in good quality and not so good quality vegetation, or healthier and less healthy vegetation in infrared image. Chapter 4 answers the question, how is GIS used for archaeological investigation? In short, GIS enables overlaying multiple layers and extracting information from them. Our presentation in this chapter is deliberately limited to the application domain, that is archaeology, and at a scale that covers the spatial context of the site to avoid overwhelming readers who are unfamiliar with GIS with complexities that a general introduction to GIS must necessarily address. Here in this figure is just show how an old map of Agra, this is the bend of river Jamuna at Agra, so how georeferencing and overlaying multiple imageries makes it easy for us to analyze the changes. Chapter 5 presents 5 case studies. So there are 5 sites for which more detailed analysis has been presented in the book, whereas there are many other sites which we give as example of a particular kind of interpretation that we discuss. So why have we selected 5 case? Well, have I selected 5 case studies is to demonstrate that there is no fixed answer to the question, how should I conduct geospatial analysis for sites of interest? That means I don't have one equation or one formula to say, this is the way you have to do for any sites in the country. So there is no one formula for that. This chapter also re-emphasizes the core ideas presented in chapter 2, 3, and 4 in more complex settings. In our experience, there is no fixed or formulaic approach to geospatial analysis of archaeological sites because the process of analysis is sensitive to variation between the sites. These variations can be grouped into 5 principal categories. Number 1, variation in the features of interest. This will vary across sites in terms of their scale, their architectural sites. For instance, Mughal sites have a specific kinds of patterns, and Buddhist sites can have a different kind of patterns. So every site, based on its cultural background, will have a different pattern that is visible. Number 2, variations in the natural setting and subsequent natural changes. Sites vary in terms of their terrain, whether it's in flat plains, hills, etc., as well as their exposure to natural processes such as weathering, floods, etc. Number 3, anthropogenic changes, such as sites will vary in terms of subsequent human activities and their impacts. Sites may be in cities, or sites may be somewhere where a dam was built, or sites may be somewhere where a harbor was built, and so on. Number 4, satellite imagery. Data from satellites may be plentiful in some sites, but limited for others. This difference is very low. I mean, the variation in this might be the most low, especially with satellite imagery. This may differ if it is LIDAR and so on. Number 5, historical spatial records. That is, the quality and quantity of such records may similarly vary across sites. Some sites may be well studied. There may be excavation that have happened. There may be many reports. Some sites may not have. So that kind of background information also can vary. The purpose of this chapter is to illustrate how the process of analysis responds to these variations. Thus, we have carefully chosen 5 sites so that there are significant variations across these sites in each of these 5 categories. The 5 sites are Nalanda, of which I already spoke a bit about. What this figure shows is, apart from the immediate surroundings, features in the immediate surrounding of the protected area, which I already discussed, we also were able to see a pattern of water bodies in the larger area, plus a paleo channel that connected these water bodies to the nearest river. So water was drawn from the nearest river towards this water body. So this is one of the case studies. Agra was the Mughal capital, as we know, and probably most of us, if not all of us, have been at least once in our life to Taj Mahal. Here is a map of Agra made in 1720. And this shows a layout of Agra where it had about 50 riverfront gardens. You can see the small squares that surround both sides of the river. And today, what we have is very few compared to this number of 50 gardens. Plus, it also had 2 city walls. So here is a result of our analysis. In yellow, we have marked number 20 is Taj Mahal, 28 is Agra Fort, and a few more which are protected locations. But we also have been able to identify all these around 50 gardens that actually were flanking the river. Of course, most of it is built over now, but there are some, especially on the inner curve, that are still sort of in a plantation mode. And also we were able to do through a geospatial analysis, identify where the fort walls or the city walls existed. Lal Bagh Palace Garden at Srirangpatna. The famous one in South India is the Bangalore Lal Bagh, but there was a namesake palace garden in Srirangpatna as well, which was laid out by Tipu Sultan. And using old maps and satellite imagery, and also some hints from ground, some ruins which we could see from ground, and hints from some old paintings, we were able to identify where this Lal Bagh Palace garden was and what was its layout. Talakadu is a site that I started working first. It is a site which is in the inner curve of River Kaveri. And it's a very unusual site, as there is a huge point bar sand deposit that has got accumulated, burying the old settlement. And using satellite imagery, we were able to identify the a canal which connected, which drew water from the nearby dam to the settlement, and also a wall, enclosure wall, and an area which had cultivation and also a reservoir. So these are the larger layout patterns. For this particular site especially, we were able to give this input to a group from Mysore University and Karnataka State Archaeology Department, who were excavating this site, and they were able to also perform excavation on the location that we identified, on one location that we identified. Mahabalipuram is another very unique site. Of course, I have not given the dates of each of this site. They are famous enough, but we also try to make it as varied as possible, though we haven't really gone looking into prehistoric sites so far. I hope I will be able to do in future. Nalanda was active between 4th and 12th century. Agra, of course, much later, 16th, 17th, 18th century. Lal Bagh Palace was active in 18th century. Talakadu from 5th century onwards, and Mahabalipuram 8th century onwards. So in Mahabalipuram, we were able to use a portolan chart or a maritime chart which marks some monuments, and it marks a very different kind of shoreline, which we used as a indicator to see where these monuments that gave the site the name Seven Pagodas were stands. Because the popular assumption is that out of the 7 monuments, only one stands, which is the shore temple, remaining have gone underwater. But actually, what has happened is the water has receded, and the actual 7 pagodas are standing further inland. Chapter 6 explores the question, how can geospatial analysis be used for preserving, conserving, and managing cultural heritage sites? It is titled Site Protection Boundaries, a Double-Edged Sword. To demonstrate that if one did not have protection boundaries, for instance, here is an unprotected site affected by widening of Airport Road in Bangalore. Can you see how it was in early 2000s and how it has become now? So boundaries are important. If we don't have boundaries, this is what will happen. Here is another example. An armory from Tipu Sultan's time had to be removed, spending crores, or had to be moved, spending crores, to make way for doubling of railway. But see, this is the problem when there is no boundaries set for protecting these sites, because of the premium on land and need for land for other public and maybe private purposes. Many sites get destroyed or damaged or moved in the interest of other reasons. So when we don't have set boundaries, see, again, in this case, the railway doubling project was taken up when the knowledge of this particular armory was not there, and then it was too late to take. So when we don't have boundaries, this happens. But let me show you what happens when we have boundaries. Here is, but see what having boundaries can do. Look at the amount of urbanization in the landscape of Bodh Gaya from around the time it attained World Heritage Tag to now. It attained World Heritage Tag in 2002. And look at the most, it's not the most recent image, but recent enough to see the changes. One wonders, is recognition really protecting the site? Nalanda was tagged as World Heritage by UNESCO in 2016 with a core and a buffer zone. Core zone of 0.23 kilometers squared and buffer zone of 0.58 kilometers squared. But look at the expanse of its remains. One wonders, will this landscape see the same fate as Bodh Gaya in the next 2 decades? So, Chapter 6 examines some of the limitations of current approaches and proposes GIS-enabled alternatives that address these limitations. As we saw, putting boundaries is necessary, but we need to put adequate boundaries. If inadequate boundaries are put, then putting boundaries suggests that we don't have control outside this. So development can happen outside this. So therefore, it is very important to consider all the landscape remains that are there before putting this boundary. Otherwise, the popularity of the site, like Bodh Gaya or Nalanda, will become the reason for its destruction, because once you put a smaller boundary, there will be, and the site becomes World Heritage Site, there will be a lot of demand for land in the vicinity to build hotels, make wider roads, and so on. So its own popularity can become its, the site can become a victim of its own popularity. So the last chapter, finally, chapter 7, provides an affirmative answer to the question, can geospatial analysis of archaeological sites contribute to research in other disciplines? Through 3 case studies. The first one, archaeoastronomy, demonstrated by studying orientation of sacred structures at Nalanda and other Buddhist sites. So the structures marked in red are the sacred structures, chaityas. So our analysis, as archaeoastronomical analysis, have found that all these structures which are actually facing east but not exactly east, it is slightly tilted, we are able to measure this tilt using satellite imaging. And we're able to identify that they are connected to some astronomical phenomena, rising of a particular star, which changes over time. And using that, we have tried also to date these structures. The second discipline is military history. Here is an example where we have used old maps and satellite imagery. This old map marks a particular event in 1799, where the British, several army of the British, as you can see, there is Bombay army led by Stuart, Madras army led by Harris, Wellesley's army, and so on. So where British attacked Srirangpatna, and following this event, actually a few days later, Tipu Sultan was killed. It was around that time. So there is a map, military map, showing these attacks. And this was also a famous attack because when British attacked Srirangpatna, Tipu Sultan's army had made a counter attack using Tipu's the famous Mysorean rockets, or Tipu's rockets. And they were taken aback because the British were taken aback because at that time they didn't know what was the range of Mysore rockets. They thought they had placed their armies sufficiently distant, but the range of Mysore rockets was much higher. So using satellite imagery and old map and georeferencing them, we were able to identify where the Mysore army had their had staged, from where the rockets were shot and where the rockets landed, and therefore also measure this range of the rockets. So measuring range of Tipu Sultan's rocket by analyzing satellite images together with old maps and records. The third one, coastal geomorphology. Looking at old maritime charts for studying cultural heritage also yielded understanding of how the coast has changed. So what happens with coastal maps in general? Most of the time they mark coasts, but they also mark locations that were prominent in the past, which are now archaeological sites. So we can use these locations as reference to understand how the coast has changed. Apart from these examples of contributions to other research area, this last chapter also discusses future direction for this body of research. So I refer to the 3 potential groups that this book is aimed at earlier. So the 3 potential groups of readers I referred to before are: the first group comprises of students and budding or established researchers in the field, such as archaeology, history, art history, who see potential value in analyzing the landscape in their region of interest. Readers in this group typically have little or no exposure to the fundamentals of remote sensing and GIS, and I hope that this book will flatten the seemingly daunting learning curve that they face. I was once part of this group, and I now recognize that my initial hesitancy in adopting remote sensing and GIS was rooted in a cultivated fear of science and technology. I was fortunate to have mentors to guide me past this mental hurdle. I was also a student in IIRS, and I hope that my book will similarly draw curious minds from this group into this fascinating field of research by providing them an accessible pathway. The second group of readers who I hope to interest are authorities concerned with protection of cultural heritage. Readers from this group are part of international organizations such as UNESCO, as well as national and subnational agencies. In India, these agencies include Archaeological Survey of India and each state's Department of Archaeology. Their mandate includes defining property boundaries for protecting archaeological sites and regulating changes to land use in their vicinity. This book aims to stimulate discussion among this community of professionals on how best practices in their field could be updated in response to availability of remote sensing and GIS technologies. Finally, I hope this book will appeal to readers from non-governmental bodies and private professionals who are involved in making maps and master plans for cultural heritage protection and conservation. I hope that the techniques presented in this book will help readers from this group develop more efficient and effective processes as they scramble to document and protect thousands of immovable cultural heritage artifacts before these are consumed by expanding cities, industries, transportation networks, and other hallmarks of rapid development. I want to thank my institution where I work right now, because this is the institution I did my PhD as well. So where we were able to start this area of research and also development into a somewhat of a larger group than it was before now. And I thank you one and all for giving me this opportunity, and I look forward to interacting with you. Thank you.